Okay, here's the Unit 2 review. Remember, it's worth 5 bonus points on your test if you turn it in on time. Okay, so for this first one here, this is actually going to be a test question, so make sure you get that one. So we're talking about absolute value. And when you talk about absolute value, you're talking about the distance between a number and 0. So for instance, let's say I have a number line. Well, if I find out what the distance of -5 is and +5 is, I'm really finding the absolute value. So the absolute value of -5 is 5, and the absolute value of 5 is 5, because they're both 5 away from 0. Okay, so when you're solving equations, the first thing you must do is you have to isolate the bars. So isolate the absolute value part of it. So in order to do that here, I'm going to add 5. Alright, so then when I do that, I end up with the absolute value of 2x minus 6 equals 6. And you'll notice now that that has been isolated. Okay, so since it's isolated, I'm going to break it out. So 2x minus 6 equals 6. But then I also have to find out what 2x minus 6 equals -6 is. Because again, it's all about the distance from 0. Now notice, this did not change. This part never changes. Only what it equals changes. Positive, negative. Alright, so I'm going to add 6. That gives me 2x equals 12. Divide by 2, divide by 2. X equals 6. So that's one of my answers for number 1. I'm going to do the same thing over here. So plus 6 plus 6. 2x equals 0. Divide by 2, divide by 2. X equals 0. So this has 2 solutions. Okay, on number 3, it's the same idea. I have to isolate my bars, so I'm going to highlight them so I know what to get rid of. And again, don't touch that. You do not change the x plus 2. It does not change. Alright, so this means 3 times that. So I'm going to divide it, and that gives me x plus 2, or the absolute value of x plus 2 equals 5. Oh. Alright, so now what I'm going to do is, I'm just going to start solving it. So now that this part is isolated, I'm going to solve it as x plus 2 equals 5, and then I'm also going to solve it as x plus 2 equals -5. Alright, so here I'm going to do minus 2. So x equals 3. I'm going to do it again over here. So -2, or minus 2, and x equals -7. So again, notice, this part never changed. The only part that changes is what it equals. It has to equal the positive, and then it has to equal the negative. Alright, on these two down here, you have one that's going to be less and. So this is going to be your less and. And remember, the word and means that it's connected, it's combined, it's together. So when I graph this one, it's going to look similar to that. So I'm going to solve this one together. So here, again, you have to get that isolated. Well, it's already isolated. So now I'm going to have x minus 1 is less than 3. But remember, I also have to have the negative part. So I have to have the -3 and then the other symbol. Alright, so now I'm going to add 1. Whatever I do on one side, I got to do on the other. So I got to do it over here too. So now I have -2 is less than x, which is less than 4. So that's going to be an open dot. So at -2 and 4. Okay, on this one here, this is great or greater. So this is greater than or equal to. And then for this one, it's going to be this or that. So because the graph is split, you have to split the equation to solve it. So I've got 2x minus 3 is greater than or equal to 1. So what I notice is it's already isolated, so I'm going to start breaking it off. So here I'm going to solve this one as 2x minus 3 is greater than or equal to 1. I'm going to do it over here because I think I'm going to run out of room. And then I'm also going to do this one as 2x minus 3. Now remember, because I have to have that negative there, I have to flip the sign. So flip the sign, and now it becomes a less than or equal to because of the negative. Alright, so now I'm going to solve. So plus 3, 2x is greater than or equal to 4, divide by 2, divide by 2, x is greater than or equal to 2. Okay, then I have to do it over here, so plus 3, that gives me 2x is less than or equal to 2, divide by 2, divide by 2, x is less than or equal to 1. So my final answer is x is greater than or equal to 2, or x is less than or equal to 1. Okay, so let's graph that. That's going to be a closed dot, so I'm going to put one at 1, of course counting by 2's. Okay, so there's the 1 between 0 and 2. And then it says that it's less than that, so it's going to go this way. So remember the little trick with the arrow, it'll kind of tell you which way to go. And this one is going to be at 2, so they're like almost right next to each other. And then that one will go that way. So they're really close to each other, but they're not connected. Okay, so on this one here, you're going to graph it. So the most important part is you have to know where the vertex is. So I'm going to find the vertex. Now, the inside lies. That's what I tell my students. And then I got that from a kid, actually. So he came up with that, or another teacher did, and I stole it. I thought it was a great idea. All right, so the inside lies. So even though that looks like a negative 1, I know it's a 1. And I also know that's a 3. So 1, 3. So I'm going to put a point at 1, 3, because that's the vertex, most important point. Now, because of that negative right there, I also know that it's going to open downward. Okay? And then the 2 tells me it's a stretch. So what I'm going to do is I'm going to go down 2 over 1, just like you would with a regular line, and I'm going to go down 2 over 1 on the other side. And if I keep doing that, down 2 over 1, down 2 over 1, and that's my graph. Alright, number 8 is very similar to the top 4. So really, if you just look at number 1, that will help you solve that one. Okay, so down here with the word problems, it's the same format each time. You just kind of have to know how to set it up. So the basic setup of these is you have to have x minus a number equals another number. So I'm taking the absolute value. So the absolute value of x minus a number equals a number. This number is your target. And this number is your varies by, or your give or take. Now, I told my students to think of it as biggie smalls. Okay, so there's your biggie, and there's your smalls. And again, this always has to be negative, because if not, you're going to get temperatures and you're going to get solutions that are not applicable to the real world. Like on the quiz, some people were getting negative numbers for their tea. Well, that means you're drinking frozen tea, like really frozen tea. So that has to be a minus here. It has to, it has to, it has to. Okay, so to reading this, the water temperature in a certain production process should be 112 degrees. So that's my target. It's also the biggest number. If the actual temperature differs by 13 degrees, okay, so that's what it varies by, or the give or take, from the ideal temperature, then what are the maximum and minimum temperatures? All right, so let's write an equation. So x minus 112, the absolute value of x minus 112 equals 13. So again, I have my minus sign, I have my biggie, and I have my smalls. All right, so I'm going to split it up. And the reason I'm going to split it up right away is because the bars are already isolated. So here, I'm going to have x minus 112 equals 13. And I'm going to have another x minus 112 equals negative 13. So same exact thing we've been doing the whole time. So I'm going to add 112, add 112. So x can equal 125 degrees. I'm going to do the same thing here. I'm going to add 112. Add 112, and it can also be, what would that be? Is that 99? X would equal 99 degrees. Okay, so this right here, so your max would be 125 degrees, and then your min would be 99 degrees. Okay, let's flip it over. All right, so on this one, you're actually writing an inequality. So it's the same idea, except instead of an equal sign, I have to have an inequality. So the temperature of a kiln should be 143 degrees. The product is defective if the actual temperature is more than 7 degrees. So this would be your target, and this is what it varies by. Write an inequality to represent the temperatures where the product would be defective and find the range of temperatures. Okay, so you always want it to be a less than or equal to. We're going to use a less than or equal to here because it can be 143 degrees. And it can be either of the other ones too. Alright, so if I set this up, I'm going to have x minus 143. So again, that's my biggie, or my target. I have to use less than or equal to. And then what it varies by, 7. Now again, that is already isolated, so I'm going to break it off. Actually, because this is a less than, I'm going to solve it together. So if I'm looking for a range of numbers, I know it's going to look something like that, and that's my range of numbers. So I'm going to solve it. So I have x minus 143 is less than or equal to 7. Now I also have to take care of the negative 7, and again, it's less than or equal to. So I'm going to add 143 and add 143. And I'm going to add 143 again. Okay, so it's okay. So 143 minus 7 is 136, is less than or equal to x, which is less than or equal to 150. So that's what your answer should look like. I mean, this is almost just like the test, y'all. So this is your answer as a range of temperatures, Okay, so on this one here, we're going to use the graph below to describe the transformations and the vertex. So let's first find the vertex. So I know that the vertex is at 1, 2, -2, and -3. So that means that I know it went left 2. I also know it went down 3. I also know it reflected over the x-axis. And that's because this is the parent function right here. So it flipped over the x-axis. And it's actually not a stretch or compression because you just go down 1 over 1. Okay, so if I write this equation, I'm going to have f of x equals. I have to start off with a negative because it reflected. And then in here. Now I know it moved to the left 2, but remember it lies to me. It's a compulsive liar. So x plus 2. And then to balance off the liar in here, that's down 3, so minus 3. Okay, the vertex is this, so -2, -3, and it has a max. So that's your max. And then remember, the parent function has a min. All right, on number 12, so in this one here, you're really just kind of inputting the values. So for instance, here, if I put in x here, so what I have here is I have -5, so the absolute value of -5 plus 2. Well, the absolute value of -5 is 5, and then 5 plus 2 equals 7. Okay, if I do it again, I have the absolute value of -2 plus 2. The absolute value of -2 is 2, so 2 plus 2, and that gives you 4. Okay, I'm going to do it again. Got the absolute value of 0 plus 2. Well, 0 is 0 away from 0, so 0 plus 2, and that gives you 2. Okay, I'm going to keep going. The absolute value of 1 plus 2. Well, the absolute value of 1 is 1, so 1 plus 2 is 3. Okay, I'm going to do it again. I've got 2. So the absolute value of 2 plus 2. Well, the absolute value of 2 is 2, plus 2 is 4. All right, I'm going to have y'all try that one on your own. Again, remember, you're just substituting the number in. So for instance, if I put in the -2 here, that gives me -2 plus 5. -2 plus 5 is 3. But what is the absolute value of 3? It is 3. But they're telling me here it's -3. So this would not be the answer. So you just want to go through each one and substitute in these values and then figure it out. Okay, on number 14, it says, if x minus 3 plus 1 is greater than 4, which of the following could be a value of x? So what I'd want to do here is, again, it's all about substituting in. So I'm going to do the first one here, and let's see if it works. And then if it doesn't, y'all can figure out the rest of them. So there's my x, and they're saying it's -1. So -1 minus 3 plus 1 is greater than 4. Okay, well, let's find that out. -1 minus 3 is -4. So the absolute value of -4 plus 1 is greater than 4. Well, what is the absolute value of -4? Well, it's 4. So 4 plus 1 is greater than 4. Well, what is 4 plus 1? 5. 5 is greater than 4. Oh, that's right. So that would actually be the answer. Okay, I'm only going to do one of these. Well, actually, maybe I'll do both. Okay, so here on this one, the absolute most important point is you have to know the vertex. So this vertex is at 3, -2. Now, the axis of symmetry is actually going to be that 3. And you need to write it as an equation. So x equals 3. That's what cut it in half. Now, my x-intercepts are where it crosses the x-axis. So it crossed at 2, 0, and it crossed at 4, 0. The domain on every single one of these is -infinity to infinity. Every single one. Nothing else but -infinity to infinity. Okay, so let's come back to this one. Now for the equation, f of x, I can tell it's opening upward, so I know it has to be a positive. And then if I go up 2 over 1, it's actually going to be a stretch, so there's going to be a 2 here. This moved to the right, the vertex, it moved to the right, so maybe we'll move to the right. So x minus 3, because it's a compulsive liar. And then it went down 2, so -2. So that's my equation. Now for the range, in interval notation, we want to see how low it goes. So the lowest it went was -2, so brackets, -2, and then it goes all the way up to infinity. And then the transformations were, it was a vertical stretch. It went right 3. It went down 2. So it was a vertical stretch by 2. And then it says, like, with the parent function, so just remember, your parent function starts right here. That's your parent function. Okay, on this one here, this is the equation. So it's just y equals the absolute value of x, the absolute value of x. So the vertex here is actually going to be at 0, 0. So right there. There's your vertex. Now the axis symmetry, don't get fooled by this. The axis symmetry is tracing the y-axis, but that's where really x equals 0. Okay, for the x-intercepts, it only touched once. This only has one solution. And again, that's at 0, 0. The range, again, how low it goes. Well, the lowest it went was 0. So 0 to infinity. And then the graph is symmetric to respect to which axis? Well, which axis cuts it in half? So see how the y-axis cuts it in half? So there's that. Okay, well, I hope this helped you. Please make sure you study. Please, y'all, the end of the 9 weeks is coming soon. All right, just let us know if y'all have any questions.